Okay, so I guess we can start. So let me first maybe introduce myself. My name is Bartek. I'm a founder of L2Beat. We are the community watchdog for all L2s right now on Ethereum, and we try to inform the users what are the trust assumptions, the security assumptions of all these solutions, so the users are actually aware. And I've got an amazing panelist today representing, I think, three most known projects that promise to deliver DA. So we have Avail, we have Celestia, and we have Togru from Scroll, who will, I guess, have an interesting role on this panel because he will represent Ethereum. So let me just welcome my panelists, and let me just start by saying that I've watched this panel last year. It was very docile, everybody was very nice to each other, and I think it was because maybe the space was nascent, everybody was building, but now we're like almost launching or have just launched, and things are becoming a little bit more spicy. So let's make this panel spicier and see how we go. So my first question to you guys will be, well, Ethereum community is probably considered to be one of the largest, and should Ethereum community really care about your solutions, or should they just simply wait for proto-dunk sharding and dunk sharding? So maybe let's start with Avail, and then we just go this direction.
Yeah, I think this is a pertinent question to ask. In general, I mean, if you look at the timelines, right, like proto-dunk sharding will come maybe end of this year, early next year sometime, but dunk sharding is going to take a lot of time to come because from our perspective, we've gone through the whole cycle of engineering the P2P on Avail, as I think Celestia has been on the same journey. And I think Ethereum being a system that is already securing a lot of assets on the chain, it's difficult to kind of introduce functionality, like that can potentially, like jeopardize the current state, for example. So it's going to necessarily take some time. And you're also seeing the rise of like, let's say, L2 systems, L3s on top. Like I said in my talk a little bit earlier, like each major L2 today is looking at this L3 strategy. Like ZK Sync hyperchains, Arbitrum Orbit, and so on, right? Like, I mean, everyone is looking to do that. And right now, let's say if you look at Arbitrum, which is doing a Nova, or a Starkweb, which is, like has a DAC. So all of them are operating DACs, which are pretty decentralized. Centralized. And all these L3s will require some secure DA solutions, and which is less expensive than what Ethereum like can give at the moment. Of course, the cost will go down with EIP 4844. So we acknowledge that. But in general, if you look at our architecture, and like I will agree with like with Celestia's architecture as well, in the sense that we are able to provide far significantly less cost. And quickly, before taking up too much time, like data availability sampling is massively underrated. Like it's not very well understood by a lot of people. And I think unless there is data availability sampling implemented on Ethereum, I mean, there's a lot of way to go there. And we are not really using this construction, like things like with recursive proof, ZK proving systems already in there. You are able to now give proofs, propagate these proofs to the P2P, for example, to the users directly. So something like a Starkware, which puts proofs on Ethereum every 6 to 8 hours. Someone like that can actually create intermediate proofs and pass them directly to the users. And of course, they need to wait for the proof to come to Ethereum for bridging and such. But like it's much faster verification time, right? Like, sorry, not taking up too much time, but like I think all of these points are important. Yeah.
Sure. So I mean, I think there's definitely place for multiple DA layers. They all have different trade-offs, different use cases. like for example, for Ethereum, as Anurag mentioned, per-dank sharding is just like a very small step to the overall roadmap of dank sharding. There's a set of different trade-offs. So, like for example, Celestia and Avail are more overhead minimized. Like there's no like state baggage already. So, for example, like it's more practical or overhead minimized for sovereign rollups, for example, if that's what you want to build. There's also like various different design choices. So, for example, EIP 4844, you can only fit 8 blobs without burst in a block. Like if you want to do like app chain rollups, you'll probably need some data aggregation service for that to be practical. Whereas, like for example, on Celestia and Avail, there's no specific like blob size limit, minimum blob size limit, for example. And also, of course, there's the fact that we have data availability sampling, and that's still kind of further on in the Ethereum roadmap.
Tucker, what do you think? I mean, should we consider using other DAs or?
First, should I explain why Ethereum community should care about data availability on Ethereum or no?
I'm kind of assuming that we all know that, so let's just move on.
Yeah, that was my guess as well. I feel like there's a place for multiple data availability solutions, and one thing to understand that we're trying to solve different problems. So on Ethereum, the DA layer serves as a way to separate the markets for data and execution, and also increase the capacity by separating that market. And basically that allows rollups that are deployed on Ethereum to scale better, because you can now post more data and still settle on Ethereum. For Celestia and Avail, the target market is a bit different. They're targeting sovereign rollups and protocols that don't really care about execution on the base layer, but more just want some ordering and data availability guarantees. And I think that there's even a way where you can combine the approaches. For example, Validiums can use Celestia or Avail for data availability, but still settle on Ethereum. So I don't think that there's a world where only one solution is required and only one solution is needed. We need multiple solutions, especially if they solve different problems.
So it sounds like Ethereum is targeting different users, perhaps. I don't know, Mustafa, Anurag, I mean, would you agree with that? That your target is slightly different than what is Ethereum trying to actually do?
Well, I mean, you can technically deploy sovereign rollups using Ethereum as DA, but I don't think that's like that's not something that, from a social perspective, that I think the Ethereum community coalesces around, and it's more overhead. It's not overhead optimal to have a sovereign rollup on Ethereum, because you have to also like run a node that gets the state of the chain. But ultimately, the whole point of it's modularism, not maximalism. The whole point is like it's not a zero-sum game. There's different trade-offs. Like Ethereum rollups have to have on-chain DA. So if you want to deploy Ethereum rollup, you have to use ETH as a DA. There's no way around that. If you want to do a Validium or a Celestia or optimistic chain, then yeah, you can use off-chain DA. But ultimately, it's just all security trade-offs and different design trade-offs.
Yeah, I would sort of agree in the sense that it's very difficult to demarcate the target segments in general. Like, how would you demarcate the users of a rollup with, like a Validium with the same stack? Of course, the security properties are very different, but that's the reality that we are seeing on production, right? Like, you have an Arbitrum 1 with an Arbitrum Nova. You have a Starknet with a Volition built in, right? Like, and so we are increasingly seeing this. Polygon also, like announce their Validium plans. They have a rollup, they have a Validium. And so, of course, the target segments might be different. Like some apps need the security of Ethereum, for example. But, like the rollup developers are asking for, solutions that help them target a maybe different, you can say there's a different target segment, it's the same target segment, but it totally depends on, what GTM these rollup developers. And I'm not, But yeah, I would agree that from a more sovereign roll-up kind of maybe Avail and Celestia are better options at the moment.
Okay, so let's dive in a little bit into those trade-offs so that it's properly understood. Because I think I'm actually taking it from Mustafa's talk in the morning that it's not easy to talk about these trade-offs. So on Ethereum, especially, we all know that cost of data is actually quite high for all the rollups. To pay, and obviously that translates to the cost to end users, and that's why we're exploring all these strange constructions like volitions, validiums, data availability committees, even such weird constructions like optimistic data availability schemes. So which solution do you think will be ultimately the cheapest to choose as the DA? Just, you can raise your hand, I mean.
Yeah, I mean, so I think...
Who's the cheapest? That's my first question.
You mean Avail versus Celestia, you mean? Or do you mean Validiums versus rollups kind of thing?
The one that has the most capacity?
Well, I'm thinking about typical dev team that is trying to deploy either sovereign rollup or a rollup, but for them the current DA on Ethereum is just too expensive, right? So they would come, let's say, to us, to L2Beat, and they would ask us, what do we think? Which solution might be the cheapest, and they will provide the cheapest. Essentially block space for data.
So I think there's two ways to look at this. The first way is you look at classes of different types of DA. So for example, you can say Ethereum, Celestia, and Avail are one type of its own chain DA. You have a blockchain DA. Then you have other kind of less secure types of DA, like a decentralized, a data availability committee, with a multi-sig of 7. That's what Starkware and any Trust Arbitrum have. And then you can just have a centralized DA, a single server. So ultimately, the cheapest is just have a centralized server as a DA. But obviously, that's not useful. So let's assume that we're talking about on-chain DA. So the important thing to note here is in blockchains, you cannot guarantee low-cost transactions. And the reason for that is because if you can guarantee free or low-cost transactions, then you have a denial of service problem. So I think it's not about framing the question in terms of cost, because ultimately there'll be fee markets and there'll be supply and demand. It's about framing the problem in how do you get the most throughput. The only thing that blockchains can guarantee is the throughput they have or the block size they have, because ultimately the fee or the pricing will be determined by supply and demand and how much demand there is for that specific block space.
Yeah, I mean, again, yeah, I sort of agree with Mustafa in the sense that, I mean, it's not enough to just look at the cost sense. Of course, there will be throughput, and our architecture allows us to create high throughput as well. But also we have to look at other factors like decentralization and stuff like that, right? There are a lot of factors. It will be cheaper, of course, and we can increase throughput as such. But as he said, we cannot compete with a single server doing DA, right? And there will be solutions like that. We are already seeing solutions like that, right? So the thing is, it's a trade-off between cost, decentralization, throughput, and a lot of other factors. And again, just coming back to the point, right? It's certainly cost is a factor, but we also have to look at things like data availability sampling, light lines, which provide new kind of powers to these rollups, right? Propagating the validity proofs or fraud proofs to the users directly. Can users verify that directly, for example? How can we come up with those kind of constructions? We should consider that as well.
And the light node is also an important piece because all the rollups that are running on Celestia right now, the sequences running on Celestia, they're not running full nodes. They're actually running light nodes. The sequences themselves are running light nodes, and they're not paying for RPC endpoints or running a full node. And that's just significantly cheaper than having to need access to a full node.
But that's not. I don't think that for a sequencer the cost of running a full node really matters. I run a couple of full nodes at home, and like even if you assume that I run relatively high-end hardware for that, the cost of one node is less than $1,000, and considering that like sequencers extract so much profit, potentially can extract so much much profits from MEV, etc., etc. I don't feel.
I'm not saying that's like the main thing. It's just like that's like one nuance, for example. I'm not saying it's like the main cost difference. Ultimately, it's about the cost of the DA.
Gotcha.
So what about the security then? I mean, the common argument that I keep hearing is that it's always a security trade-off to cross the trust boundaries when you actually using the external DA. So clearly, the security of Validium is very different than the security of a rollup, right? And the cost of Validium is also very different. That's why we've got Arbitrum Nova. That's why we've got StarkNet or StarkX rollups and StarkX Validiums. And I was always wondering, like end users, at the end of the day, they seem to have very little to say. Like if you are, let's say, the DYDX user, what benefit do you gain from DYDX actually posting all the transactions as opposed to them using some data availability committee, right? You just want to trade on DYDX and you want to have a reasonable guarantee that if things go wrong, you can always like recreate the state from the data and you can always exit. And it seems that this is all about the trade-off, right? So with increased security comes, I guess, bigger costs. So how do you, as an app developer or as a rollup developer, suppose that I'm DYDX, how do I make this trade-off?
Yeah, I think ultimately, I think the choice will be decided by the rollup developer, and I think not by the app developer directly. I mean, unless we're talking about app chains, for example. But before that, we are seeing like a lot of rollup orchestration players coming to market, for example. And I think these are the set of developers who are making the choice in terms of what DA to use. And at least from my perspective, what we are seeing is it's at the moment a cost versus security trade-off kind of a thing. So of course they want cheaper costs for the users. That's kind of the primary metric. But in general, from a rollup operational point of view, right? Like, I mean, at the moment, of course, no decentralized DA layer is in production, which is going to change pretty soon. And that's why you see these data availability committees and right now that may not be a problem, but I definitely see, like decentralization of the DAs, similar to the decentralization of sequencer questions that will come from a regulation point of view or whatever, right? Like, I mean, in general, people don't, I mean, for now, single sequencer data availability committees are fine, but I think just to safeguard regulatory interests and stuff like that, I think for sure, things will move to a more decentralized context.
Are you saying that this is the primary reason why DYDX chose to go, its own way and like be more decentralized?
I can't talk to their intentions, of course, but I think in general, I didn't fully comprehend the whole reason why they moved. Of course, they have more flexibility in running their own app chain as such, and so they are able to customize a lot, is what I feel. I think the StarkX solution was a bit limited, is what I may be wrong, in terms of what they wanted to do. And of course, StarkX has now, I mean, there's new upgrade, the StarkNet is much more powerful, Cairo 1.0 and such. So I can't ascribe their intentions, but yeah.
Yeah, so I think there's kind of like an interesting question here, which is about how much do users actually care about decentralization? Like, sure, from a UX perspective, there's no UX difference probably from interacting with the AC versus interacting with the on-chain DA. But consider this, like users today can use Polygon, they can bridge tokens from ETH to Polygon and use it like pretty much as the same as a L2 or a rollup, even though it's not. But if that's the case, then why did Polygon, spend $1 billion on ZK rollups? It doesn't make it doesn't actually make a direct difference from a user perspective. In fact, it's probably like slightly less TPS at the start until we optimize the ZK proving systems. I think ultimately this is what differentiates Web 2 from Web 3. From a social perspective, ultimately people do coalesce and do care about the decentralization properties of the systems they're interacting with. Like otherwise, why has no one just created, a centralized proof of authority L1, just 10 committee of 10 nodes, billion TPS. That's no one would take that seriously. So that's why I think yeah, people should use the ACs for certain use cases, but ultimately for an application to be kind of credibly decentralized and credibly have a social community around it, there does need to be at least a decentralized DA as an option.
I have a small question for you. With the whole Validium talk, are you trying to bring back the conversation whether Validiums are L2s or not? Because I had a feeling that that's what you're doing there. So I feel like it's all about the trade-offs. So because when you're building a certain application or a certain protocol, you need to assume what is the worst case scenario that your protocol can handle, and is that worst case scenario worth taking certain trade-offs? So for example, if you're building a game that doesn't really have any monetary value, then you probably shouldn't use on-chain DA because it doesn't matter, worst case scenario, your game assets just disappear, whatever. But if you're building an app that has billions worth of dollars deposited on it, I think then you should take more care of how you design things, because billions of dollars frozen in a contract that you can never withdraw from, that's a bigger problem than your game assets being frozen.
Okay, so let's maybe switch gears a little bit. So here's another common question that we get from users. Well, first of all, sometimes it's hard for them to differentiate between the data availability and data storage. But let's assume, for the sake of this discussion, that we all know, and for the audience that don't know, maybe some of you can give a very quick introduction. But the question is, on Ethereum, it seems like we have a very reasonable and strong, I guess, guarantee of the data storage, because there's this huge, vibrant ecosystem of different explorers and indexes and whatnot, and people just simply assume that it works, right? Now, if I use Avail or Celestia, how can it be guaranteed that in 12 months, I will have access to all the data and I will be able to actually recreate the state?
Yeah, so I mean, that's a general question about the difference between data availability and data storage. So, even with proto-dank sharding and dank sharding, proto-dank sharding also does not plan to guarantee the data forever. It's the current plan is to prune blobs after 30 days. And the reason for that is because data availability layer, including Ethereum / Avail, it's meant to be a real-time bulletin board to allow rollups an opportunity to get their data to make sure it's published so that they themselves can store it. So what is the difference between data? So I would actually propose renaming data availability to data publication, because I feel that's easier to understand. So data availability is about proof of publication, proving the data was published so that people can access it. Specifically in Celestia, at the moment we don't prune the data blobs. They're kept around forever right now. But at some point after mainnet, the community will need to coalesce around how, after what certain point in time, data blobs will be pruned. But that being said, even on Ethereum, even on networks where blobs are pruned, I actually still expect that the data will be permanently stored somewhere and permanently accessible to the public, simply due to the Streisand effect. It's very for data storage only requires an assumption that a single person, ideally you have more, but the minimum assumption is that you have a single person storing the data. And that's very easy. That's extremely easy assumption to achieve on the internet.
I think Bartek's argument was more that because Ethereum has such a vast ecosystem where you have RPCs, block explorers, etc., storing the data, it's highly unlikely, even if all the nodes prune the data, that the data will be lost. And so, for example, I think it was Ripple that at some point lost like a day worth of data because their servers somehow had a bug or something. So I think Bartek's question was more, sorry if I'm rephrasing it incorrectly.
Okay, I understand. But I argue that would also still happen on Celestia and other DLAs, including Abel. Like, it's the cost of running, the cost of storing data is cheap enough that multiple people will do it, even if the ecosystem is smaller than Ethereum. And also, the other very important thing to mention is that the whole point of having data availability sampling light nodes is that you're distributing data across thousands of light nodes. And that will also help somewhat with the data storage problem, assuming that those light nodes are happy to store it for a longer period of time.
Yeah, absolutely. If these light clients can make their way into wallets, for example, I think like we'll have the data mirrored from the D layer to the light client network, and that can be propagated, kept for a long time. Second is like just a point that if you look at the stack that we've built on, like we've built on Substrate, Celestia is built on Tendermint, for example, and so a lot of the tooling in these ecosystems is also compatible, like with the stack in general. So, and in fact, like we are also starting to work with a couple of teams who want to put avail data onto IPFS, onto Filecoin, for example. And so, as Mustafa said, like ideally you just need only one copy of the data. But we are expecting that, we've been working with a few infrastructure providers in the Substrate ecosystem, for example, and there is the tooling, the ecosystem is more mature than, let's say, 2, 3, 4 years ago, like in all these ecosystems, in the Substrate ecosystem, in the Tendermint ecosystem, for example. And so we don't really have to build all of this tooling from scratch. And there are a lot of, providers out there, but as part of the architecture, we already have a light client network that mirrors the data, and so, so we don't anticipate the kind of problems that Togrul is mentioning in that sense.
Okay, so you represent, I think, to my knowledge, the 3 most known on-chain data availability solutions, but very recently, it seems like there's a new kid on the block somehow, and everyone seems to be talking about it. And I mean EigenDA. Any of you have a spicy take on EigenDA and the trade-offs and its role in this DA kind of landscape?
Just before I go on to express my opinion, I would like to add that I don't represent EF, just in case Dan Cred kills me if I say something wrong. I just accidentally stumbled on stage. I think from the perspective of Ethereum, EigenDA makes sense because it utilizes the existing validators or a subset of existing validators to offer extra capacity that is much cheaper than on-chain DA. Obviously, the security guarantees are much different, so it's not comparable with just...
Yeah, what are these security guarantees? Isn't it just a fancy name for data availability committee?
Yeah, I'll make things spicy. Like first of all, there's no docs on EigenDA, so it's very hard to even compare it in the first place. Like people keep saying, oh, Mantle claim to...
Yeah, they launched, right?
They claim to launch the mainnet on EigenDA, but I have other people are saying no, it's not actually. I have no way to verify that because there's no docs anywhere, and it's people say use EigenDA, but there's no docs. So when there's docs, it will be easy to compare. But from what I know so far, there's a various set of trade-offs. First of all, I'm very skeptical of the idea that you'll actually be... Okay, so first of all, I'm skeptical of the idea that there's enough demand for restake services. I think there's enough supply. There's a lot of supply of validators wanting to restake. Very skeptical there's demand. Because that at least it's very hard to bootstrap your rollup if you're saying the to convince validators to come and restake if the initial rewards only come from fees, which might be very small to start at the beginning. And the whole point is that the fees are supposed to be cheap in the first place. Secondly, as far as I know, EigenDA requires a dual token model anyway, because you can't slash data on chain. And so it kind of defeats the whole point of restaking, in my opinion, because you have to restake not only ETH, but you have to restake the eigen token as well.
Yeah.
Because you can't slash data on chain.
Yeah. So I was about to add on this. I'm still not sure if that's a very sound model, the whole data availability based on cryptoeconomic guarantees, because essentially the assumption is that if the data is withheld, then the price of the staked eigen token is going to drop, and it acts as a disincentive. So essentially you can see it as implicit staking, like the one that Chainlink used before. And I'm not really sure that it's a strong enough guarantee for a lot of applications. Obviously, as I said before, some applications it's fine, but like for a lot, I just not sure if that's because it's also potentially vulnerable to griefing attacks the same way Metis's DA solution is. So yeah, I'm not sure.
Well, I don't want to like attack EigenDA too much when they're not here to defend themselves.
Yeah, that's true. I mean, I think last year's panel, Sriram was there, and I really like him. But we have yet to see a working system. Like I haven't seen that, so I would reserve my judgment based on that first. But yeah, I mean, restaking, like not about EigenDA, but restaking itself is, like it's a pretty neat idea. But I'm still skeptical of how it will actually work in production settings. In terms of like how many validators sign up, what is the actual security, like griefing attacks, such and such. So I would want to reserve my judgment. At least like I want to see something working before worrying too much about it.
Actually, like from my point of view, what I would love to see more is like more, I think, thorough security analysis of such potential attacks like griefing. We had a discussion about that about 2 years ago, or maybe it was a year ago, when Metis launched so-called Smart L2 and Optimistic DA, which for those that they seem to be publishing data directly to the storage without actually mentioning the DA layer. And if anyone notices that the data was not published to the storage, they could, in theory, challenge the sequencer and force somehow sequencer to post the data on chain. So, and the cost of such solution, as you can imagine, is extremely low. Hence, fees on Metis were very, very low. And I was surprised that very few people actually bothered discussing that from first principles, right? I mean, what are the security, trade-offs there, and is that scheme actually viable to consider for anyone? The community was largely silent.
Are you talking about? I looked at Metis' profile on L2Beat up before this talk, and the idea is to use a data availability challenge, right? But the problem is with data availability challenges is that that's they have, as far as I know, they haven't actually. There's no challenge mechanism finalized or proposed yet. But in general, the general problem with data availability challenges is that they don't solve the data availability problem. That was actually the first thing that people like Vitalik looked at to solve the data availability problem, but it doesn't solve it because of something called the fisherman's dilemma, which is where because data unavailability is what's called a uniquely unattributable fault, which means that the challenger who's challenging the data availability, it might be their fault that they can't access the data. It might not, because maybe their network is not good, and that basically creates a dilemma where it's explained on the Ethereum wiki, but it's you either have a situation where you have a DOS attack, or there's not enough incentive to make a challenge. There's no incentive to make a challenge in the first place because the DA publisher might only release the data after we make the challenge, and so they're basically griefing you. So there's no way to make it economically sound, basically.
Yeah, it's basically as Mustafa described, because the fault is not attributable. It's impossible to attribute the fault here. You would essentially, let's say, if I create a challenge and you post the data, you can both withhold it, and you could have withheld it before, and that's why I initiated the challenge, or I was just not in sync with the network, and that's why I didn't receive the network. And that creates a long-term griefing vector, where essentially you start the challenge, you stake a certain amount, I post the data, when you initiate the challenge, you get slashed, and then you continue to get slashed until nobody is willing to challenge you anymore, because basically every time you slash, the sequencer just reveals the data, so there's no reason why you would long-term continue challenging it. And therefore, it's fine if you consider the optimistic case, but in a worst case scenario, this whole security basically breaks apart.
Okay, so I have another question, like from a completely different angle. So you guys mentioned, and this is the thesis that we've been hearing and will be hearing, especially in this conference, it will be very easy for anyone very soon to launch their own construction on rollup with very custom security parameters. And as it is, even today, for users to understand the security assumptions is extremely hard for us as an org trying to understand that. We're like really, for us, it's a moving target that, we need to chase. How do you see in the future with potentially thousands of rollups being launched, how do you envisage that users will be actually able to tell what are actually the security assumptions, and how do you see the role of people like us in this whole space? I'm very curious because I'm frankly terrified about the future you're describing from my perspective.
So the way I think about it is, there is like a wide variation in terms of rollup orchestration today. But as you're increasingly seeing, all the rollup stacks are also tending towards standardization, right? Like, so for example, like ZK EVMs in terms of the implementations, are going in like a similar direction as such, for example. So that process will also apply to the entire rollup stack pretty quickly. I mean, better than anticipated. And as I said, right, like a lot of these, the major players are pushing their standardized stack to, like these rollup as service providers or such, for example. And so what we feel is, rather than having a wide variation of rollups, there will be a set of rollup stacks that will be pretty much standardized, and the deployment itself also will not be like 1,000 different rollup configurations. It will be like maybe 5-10 different configurations, but like a lot of instances in that sense. And so it'll be easy to kind of look at it. Of course, it's not going to be as easy as I make it out to be, but yeah.
Yeah, I think people should just use L2 beat. Like that's the solution. I'm relying on you guys. You guys are doing a good job so far. To be a credibly neutral and trusted way for users and developers to get quick information about the security trade-offs between the A layers and the rollups and L2s.
I think we opened up a can of worms by John specifically. I blame John Charbonnet for everything by writing that article about social consensus or how rollups aren't real. Because now, for the last 3 weeks or a month, I've been hearing people making ridiculous claims about, like, Anatoly. I love him, but like his argument that if I post data on Ethereum, I'll all of a sudden become an L2, it just doesn't really make sense. And so I feel like first, before like we start discussing about how many rollups are going to be built on a different protocol, we need to work together to define what a rollup actually is, because I don't really buy that whole social consensus thing, because you can literally attribute it to anything, and therefore, like, all the concrete properties that we have about consensus protocols, signatures, etc., can be just hand-waved away through social consensus. And so I think we need to start working on that first before we discuss what's going to be deployed where.
And we've just run out of time, so that might actually open the discussion for entirely different panel. So. Thank you so much, guys. I mean, it was lovely to have you all here. Unless you've got like one last closing comment, Mustafa.
I mean, you forgot to ask the spiciest question, which is like, what's the throughput? But I guess we're out of time for that, unfortunately.
All right. Thanks so much again.
Thank you very much.
Thank you.